everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today, the topic for discussion is Introduction to Laplace Transforms. This video lecture includes, we are going to discuss in detail about definition of Laplace transform, sufficient condition for the existence of Laplace transform, piecewise continuous function, Laplace transform of elementary functions, and Laplace transform of elementary functions to be used how while solving the problem. So everything in detail we will discuss in this video lecture. Definition of Laplace transform. Let f of t be a given function and defined for all positive values of t. That is, the function which contains the variable t, the t has only the positive values. Then Laplace transform of the function, that is f of t, is denoted by L of f of t. This is how we have to read. Capital L represents Laplace transform. That is, Laplace transform of the function f of t, or it can be written in other way, f bar of s. So L of f of t or f bar of s, which is defined by, so Laplace transform of the function f of t or f bar of s, it's nothing but the function f of t which is multiplied by e power minus st, and we have to do the integration with respect to t from range from 0 to infinity. This is the definition of Laplace transform. That is integral 0 to infinity e power minus st f of t dt. Compulsory the integral should exist. And here this s is nothing but, it is, that's what it is written here, the parameter s is a real or complex number. Now, the operation of multiplying f of t by e power minus st, that is, we know the definition of Laplace transform e power minus st f of t dt. That's what here, e power minus st into f of t, that's what it is written here. The operation of multiplying f of t by e power minus st and integrating from 0 to infinity with respect to t, 0 to infinity, and we are doing the integration with respect to t, is called Laplace transformation. Now, we know it L of f of t equal to f bar of s. Now this L, we will push it here. Then f of t equal to L inverse of f bar of s. That's what it is written. Now the function f of t, now this is L inverse. The function f of t is called inverse Laplace transform. The symbol L which transform f of t into f bar of s. We know it, this f bar of s, it's nothing but L of f of t. So f of t into L of f of t, the work which is done by capital L is called Laplace transform operator. Whereas the symbol L inverse, which transforms, we know it, f bar of s, it's nothing but L of f of t. That is, from L of f of t to f of t is called inverse Laplace transform operator. L is Laplace transform operator. L inverse is inverse Laplace transform operator. Now, this Laplace transform to exist, what is a sufficient condition? That is, the sufficient conditions for the existence of the Laplace transform of the given function is the function f of t must satisfy the following conditions for the existence of the Laplace transform. So to exist the Laplace transform, what are the conditions? The first condition is the function f of t. Here it is a formula, we are explaining the definition. That's what it is. F of t we have taken in general. In the problem, f of t may be sin t, cos t, or any function it will be given. So the function f of t must be a piecewise continuous or sectionally continuous. In any limited interval, the t lies between a and b and everything is greater than 0, that is positive. The second one is the function f of t is of exponential order. That's what the definition of Laplace transform is. Integral 0 to infinity e power minus st f of t dt. So the f of t is multiplied by e power minus st. So it is in exponential order. Now, the definition of piecewise continuous function. A function f of t is said to be piecewise continuous over the closed interval a comma b if it is defined on that interval and is such that the interval can be divided into a finite number of sub-intervals. Suppose, we know it, suppose 2, 10 it is there. That is from 2 to 10. The interval, closed interval, the 2 is also included, 10 is also included. Open and end, the points are included. This 2 to 10, we will give you a break. 2 to 5 we can take. Next to 5 to 6 we can take. 6 to 8 we can take. 8 to 10. They are divided into sub-intervals. They are finite. We are able to count. It is finite. So in each of which f of t is continuous and has both right and left hand limits at every endpoint of the interval. So we can see it now to understand more. The example for piecewise continuous. Now, if t lies between 0 to 5, so 0 to 5 between, we can take 1, 2, 3, 4. The function is t square. So we know it like this: 0, 1, 2, 3, 4. So when we substitute here the t square, if it takes a value 1, so 1 it is there. If it is taking 0, the value we are getting 1. Sorry, not a 0, it is not possible because t lies between 0 and 5. So 0 is not included and 5 also not included. So 1 I am substituting. So if it is 1, we are getting 1 only. Then 2 I will substitute. So 2 if you are substituting, we are getting 4. So somewhat here. So joining, we will get some one curve we'll be getting. Yes, fine. Next, t is greater than 5. So 6 onwards, 6, 7, up to infinity it goes. So that we will substitute here. So we will be getting some points same like that we will be joining. So here for this one curve, it continuous. For this another one curve, it continuous. Such type is called piecewise continuous. That is 0 to infinity is divided into sub-interval 0 to 5, 5 to infinity. These sub-intervals are finite. This is piecewise continuous. Now, one more example, we can look at here. F of t equal to 1 by t, the function. Here we noticed the first example, t square is given. Fine, because it is 0 to 5, 1, 2, 3, 4. Anything among the 4, any one we can select, we can substitute, we are going to get some value we are going to get. Fine. Here also the same, 6, 7, 8. We will substitute one value we are going to get. Whereas the second example, if you notice, f of t equal to 1 by t is given. It is not a piecewise continuous. Why? What is the difference? The first one we are seeing piecewise continuous. It satisfies. Whereas the second, the function, it is not a piecewise continuous. The reason is, whatever interval, suppose the interval contains 0 is also included. Suppose like this it is there. Sorry. Suppose if it is there, 0 is included. So if we include a 0, whatever the interval it is given in the question, we will substitute in the place of 0, 1 by 0, we are getting infinity. That is the reason at the particular point t equal to 0, for this function, it is not continuous. I hope so. Now, these two examples, which gives a clear picture about piecewise continuous. Next, Laplace transform of elementary function. We are taking one L of t equal to 1 by s square. That is already actually it is proved it. How to? We got this answer 1 by s square. That we are going to see. So our function is t. So for that, Laplace transform of f of t, L of f of t. How we will read it? Laplace transform of the function f of t. Our f of t is now t. So now the Laplace transform formula is defined by L of f of t equal to this f of t is multiplied by e power minus st dt, and from 0 to infinity. Now, so our f of t is t. It is replaced. That is, in the place of f of t, we substituted t and we have to do the integration. So the integration, this is with respect to t, we have to do the integration. The first one is t. The easy way to avoid the careless mistake, t, that is algebraic oriented. The differentiation is 1. Sorry, here we can write it. t, the differentiation I wrote it 1. Here e power minus st. We will do the integration, very simple integration by minus s. So e power minus st by minus s. Next again we will do the integration minus st by minus s. Again one more time minus s. This integral, if it is algebraic and exponential combination, we can use it this one. That is first algebraic, that it is written. This exponential integrate and we wrote it e power minus st by minus s. Then algebraic oriented, we are doing the differentiation 1. This exponential oriented, we will do the integration. So e power minus st minus s, already minus s exists, that's what written here. Now one more, the third step, I am not going to write. The reason why we stopped, main reason is now t differentiation is 1. 1 differentiation is 0. So that's what we stopped the before step itself. That is the main idea behind this, the concept behind this integration is we selected the algebraic oriented for differentiation. Then only integration will come to an end. If you selected this exponential term for never-ending processing, if you select algebraic oriented, it will come to an end. So now t1, next 0. Yeah, we will come to here. Now the algebraic oriented, this one, this both we multiplied and put it here. This is formula sign. And these two multiplied and we put it here. So we can see it now. Yeah, we can see algebraic oriented. We did the keep on differentiation. This is formula minus. Exponential, we did integration and we put it. Keep on, we have to do the integration. Suppose one more term it is there. Then here formula minus minus, here next it will come plus. Next it will come minus. That means alternative signs keep on, it will be going on. This integration if we do this type 0 to infinity. Now before actually substituting the limits to avoid the careless mistake, so many here minus sign is there, here minus sign, here minus sign. So we will make it the signs will come to an one order. So t, this minus sign, here plus is there. So we kept it minus, a single sign. Minus s the whole square. So s square, we know it minus the whole what even it is there. So we know it a negative power even is positive. So here the minus is there, fine. So e power minus st by s square, 0 to infinity, fine. So e power minus infinity, the value is 0. E power 0, the value is 1. So now, so here the upper is what? Infinity it is there. Which place we have to substitute? In the place of t. So here e power minus infinity, here also e power minus infinity. Totally the upper one it has become 0. This is formula minus. Upper minus lower. So the lower one is 0. So 0 into anything 0. Here minus. E power 0, the value is 1. This is formula minus, this is problem minus. The negative sign comes, we have to be very careful. The signs, the playing the role, whether the sign it is in formula or it is in our given problem. Now this is in the formula sign, that is upper. What is the infinity value minus the lower limit value? This minus this one. This is minus is problem minus. So e power 0, the value is 1. So minus 1 by s square. So minus into minus plus. So 1 by s square. So we got it. Laplace transform of L of t equal to 1 by s square. So the function, it is a very elementary function, t power 1. Straight away, while solving the problem, if it comes, we can write it 1 by s square. So the previous problem, L of t power 1, we got it 1 by s square. The same procedure, if you continue, L of t square, we will get it 2 factorial by s cube. That is generally t power n equal to n factorial by s power n plus 1 we will be getting. Yeah, the next problem we can see it. Find the Laplace transform of cos h cube 2t. So first we have to read the question carefully. Cos h 2t. If it is only cos h a t, we have a formula. That is, just now we discussed that elementary function L of t. That is, f of t is a t. We substitute, we integrated, we got it 1 by s square. Similarly, this is also an elementary function. Same the procedure if we substitute. If we do the integration, we will be getting s by s square plus a square. Sorry, minus a square. But here cos h it is there, it's okay. But here we have cos h cube. So if the trigonometric terms are dominating in our equation, in the problem, if they have power, the relevant any trigonometric formula we have to substitute. The first point we have to keep in our mind. So now, so the given, so a Laplace transform of, in mathematically, L of cos h cube 2t. Now cos h 3a, the formula is 4 cos h cube a minus 3 cos h a. Our problem is cos h cube 2t is there. In the formula, a it is there. So we will substitute wherever a, 2t we will substitute. So we substituted 3 into a, 6t. This 4 cos h cube, in the a place we substituted 2t, and 3 cos h, a place we substituted 2t. Now cos h cube 2t, it's nothing but cos h 6t. This we are bringing here plus 3 cos h 2t divided by 4. It's a very simple thing. Cos h 6t, we have 3 cos h 2t divided by this 4. That's what it is written here. So now, so the equation cos h cube 2t, first we simplify it because we have in our hand the formula which is available with us, only cos h a t only Laplace formula is available with us. The point should be very clear. So according to that, how to modify our question? Yes, we modified with the help of this trigonometric formula. So 1 by 4 of L of cos h6t plus 3 cos h2t. Now 1 by 4, we know it, cos h at, it's nothing but s by s square minus a square. Our a is playing a role in the first, the formula, the function 6. So s by s square minus a square, our a is nothing but 6. So a square is 6 square, that is 36 is written there. Next, plus is as it is plus. The 3 is as it is 3. Next, here we have to substitute cos h2t. That cos h2t, here the a is playing the role 2. So s by s square minus a square, that is 2 square. It's nothing but 4. Now, here yes, so we have taken out. So 1 by 4, 1 by s square minus 36 plus 3 by s square minus 4. This s we have taken out. That's what here. Next, s by 4, we will take LCM. So s square minus 4 plus 3 into s square, 3s square minus 108 divided by s square minus 36, s square minus 4. Yeah, fine. Now, s square plus 3s square, 4s square, 4 minus 108 minus 112. So, in this, here and here, 4 is common. So, we have taken the 4 out. So, 4 by 4. The final answer we got it. S of s square minus 26 divided by s square minus 36 into s square minus 4. Yeah, we will come to one conclusion of this topic, introduction to Laplace transform. First, the definition of Laplace transform we discussed. That is L of f of t. It's nothing but f bar of s. So the formula is whatever the function which is given, f of t is multiplied by e power minus st, and we have to do the integration with respect to t and range from 0 to infinity. This is the definition of Laplace transform. Then the existence of this Laplace transform, what are the conditions? First, it should be a piecewise continuous. That is, piecewise continuous, it's nothing but it is divided into finite number of sub-intervals. And it should be, the function should be in exponential order. That is multiplied by e power minus st. These two conditions are sufficient for the existence of Laplace transform. And we did one problem, we solved it, that is cos h cube 2t. So we gave very importance while solving the problem, especially if you face the trigonometric terms are coming as functions, if they have power. So the relevant, the power to remove, is there any trigonometric formulas are there, we should replace it. The main reason is which available formula we have suitable Laplace transform formula. According to that, we are selecting the trigonometric formulas. And the Laplace transform of elementary function, that is, we have selected f of t as t, then we derived it, we got it 1 by s square. So L of t, it's nothing but 1 by s square. That is also we solved in detail. Thank you very much.
Like, share and subscribe. hit the bell icon for more updates.